With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start this question, and the question says that a projectile is fired with velocity v0 at angle 60 degree with horizontal. At top of its trajectory, it explodes into three fragments of equal masses. First fragment retraces the path, second moves vertically upwards with speed 3v0 by 2. Speed of the third fragment is which of the following? So here if we consider the projectile fired at an angle 60 degree which is given, and the initial velocity of projection is v0. So initial velocity of this particle will be v0 cos 60 degree along x-axis. So vx will be v0 cos 60 degree, that is v0 by 2, because cos 60 is 1 by 2. Similarly, initial velocity of projection along y, it will be v0 sin 60, although we don't need to do anything with this component, because at the highest point it is stated that the first particle retraces the path. That means the velocity of the first particle should be horizontally to the left, and its initial velocity at this point, if we assume, it will be minus v0 by 2, because at the highest point the velocity is horizontal and the second particle moves vertically upward. So second particle moves vertically upward with speed 3v0 by 2, and the speed of the third particle we have to find. So assuming that the third particle will have x component and y component velocity, so let us say those x component and y component of third particle will be v3 along x and v3 along y. So we will find v3 and vy of 3, and then we will find the speed accordingly. So here if we observe on this system, there is no external force. So the external force acting on this system is 0, and hence the conservation of momentum will be valid. So first we use conservation of momentum along x-axis. So here, assuming that the particle has mass 3m, which is fired. Now the initial momentum of this particle at the highest point, since the particle will be having the x component velocity, so initially its velocity is 3m into v0 by 2, and this will be equal to the final momentum of all the particles. So since the second particle is moving along y, we will not take it into consideration, but one particle is moving horizontally in the left direction, so it will be m into minus v0 by 2 plus m into velocity of third particle along x direction. So here we can cut m from both the sides and we get 3v0 by 2 plus v0 by 2 is equal to v3 along x, and solving this gives us v3 along x as 2v0. That is first equation, let's suppose. Similarly, we apply conservation of momentum along y-axis. So here initially the particle is not having any component at this highest point. Particle is having only the horizontal velocity, so its initial momentum will be 3m into 0, and this is equal to particle 1 has no y component, so its initial final momentum will be 0, and particle 2 is having 3v0 by 2 along y, so plus m into 3v0 by 2, and the third particle, let us say it has velocity v3 along y. So we solve this and we get v3 along y as minus 3v0 by 2. So observing equation 1 and 2, we can say that the third particle has velocity v3 equals to 2v0 along I cap and then minus 3v0 by 2 along y direction. So we were required to find out the speed. So speed is just the magnitude of this velocity. So that will be root of 2v0 squared plus 3v0 by 2 whole squared, and this gives us root 4v0 squared plus 9 by 4 v0 squared. So this gives 25 v0 squared by 4, and the speed comes out to be 5 by 2 v0. So option B is the correct one. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.